My new book, Facts That Aren't True, is out now. Don't forget about my other book, Rational Answers to Stupid Questions. Click the link in the description now. I would say we know the Earth isn't flat. It's literally impossible.
Why is it impossible?
Because all descriptions for it necessarily contradict other explanations that supposedly make it work. And it's contradicted by, there isn't a single observation that conforms with a flat Earth model. Not one. Like, literally not even one.
You said there's no observation that conforms to a flat Earth model?
That is correct.
Well, I disagree because whenever I observe the Earth, I see no curvature. It looks pretty flat to me. Besides
You
the
do see
hills.
curvature, you just don't know what you're looking at.
I'm looking outside right now. I'm about 20 feet above the air, and I don't see any curvature.
Cool. Are there clouds?
Yeah.
Do those clouds converge with the horizon?
What do you mean converge?
Do those clouds, as you look at them farther and farther away, do the clouds just simply, does there appear to be a line, the horizon, and then the clouds just are below that line?
What line are you talking about? I see trees. But if you're talking about the horizon, yes, those clouds do. I guess they do converge. Yeah.
Yep, there you go. If the Earth was flat, then the sky never actually converges with the horizon. That wouldn't happen. You wouldn't have a sharp horizon. Now you could if there's like mountains around you, depending on the topology, but if it's relatively flat, that would not happen. The sky would just fade into obscurity, but that's not what happens. That's not observed anywhere, ever, at any time. Have you ever been to the ocean?
I have been to the ocean, but I can't disagree.
The horizon is a sharp line that is not possible if the Earth is flat. It would fade into obscurity.
I disagree.
That's because you don't know what you're talking about. You don't know how to think.
No. So when it comes to the flat Earth, you can still have clouds that converge. It wouldn't necessarily fade into obscurity because number one,
It's exactly what it would do.
not necessarily. I mean, so if I was to, like, the reason why you wouldn't see, let's say, I think, I mean, you would still see the clouds converge because of distance, right? So let's say if you were in a tunnel, right? And somebody, let's just say they kept running and running, the person would fade into obscurity because you can see the person disappearing from all four, like from all four sides, because the tunnel has. Well,
Yeah. Notice how nothing does that except for objects that are already like quite small, right? Like perhaps an airplane. Does the sun do that? The sun is always above us, and the clouds are always above us. The ones, as they get farther away, do they change in size to the point where they just simply get to the point where the angular resolution is such that we can't see them? No, that's literally never happened.
Well, the reason why it doesn't happen because
the Earth is curved, and those objects are going below the curvature of the Earth, which is why we have a sharp horizon.
well, the reason why that wouldn't happen on a flat Earth is because
No, it would necessarily happen because they're always above us, and the thickness of the atmosphere would obscure it at some point. Just like with fog. When we have fog, you can see things it's different because we're not getting the receding thing until the angular resolution can't be made out. But they would fade into obscurity or disappear by getting smaller. But the sun, the moon, the clouds, they don't do that. They never do that.
Well, well, again, the reason why it's because of distance. Like, do you know how big the Earth is? I mean, why would
40,000 kilometers in circumference. Do you
yeah?
know how big the Earth is?
I mean, circumference, yeah. I mean, that's not circumference. I mean, circumference wouldn't necessarily be real. I mean, because I mean, like I said, Earth is
Well, it is. We know it is. It's been measured.
It's been measured.
Yep.
Do you have do you have proof it's been measured?
Eratosthenes did it 2,500 years ago. You could do it today.
How?
You just get the angle of the sun in two different places and do some calculations. Now, that would assume that the Earth is a globe, but all you have to do is take further calculations, because if it actually is a globe, then that means that those calculations hold true every time you try to make them, and they do. Whereas if you try to measure the angle of the sun on a flat Earth, that's very simple trigonometry. You can establish a baseline of, okay, what's the altitude of the sun based on its angle here? And it's best to just pick like the equator on the equinox or whatever, because that would be 0 degrees. And then you can use that and say, okay, well, now I know what the angle of the sun in the sky would be in other locations. And every single time you do that, you will fail. You will get the wrong answer. So that's how we know.
I mean, but how does that necessarily prove that the Earth is a circle?
Because the mathematical observations always ring true.
The mathematical.
You know how science works.
Wait, you said the mathematical observation always rings true. So you're basically, but I mean, sure, the mathematical observations may be true, but
yeah, and the flat Earth ones are false. So we can throw out flat Earth. We know evidentially that it can't be true. Not that we haven't found evidence yet. No, we know exactly what the evidence would be, and the evidence has undoubtedly proven that it is false.
evidence have undoubtedly proven it. I mean, wait, are you saying that so you're saying that if the Earth was flat, you wouldn't be able to measure the Earth with the sun?
You would be able to, and we know what the measurements would be. However, the measurements are always wrong.
Oh, okay. So
do you think that I'm 9 feet tall?
no, I don't think that.
Okay, I do think that I'm 9 feet tall. How could we figure it out?
We could figure out using inches, 12 inches each.
So we would measure me?
Yeah.
There you go. So we have taken these measurements with the Sun-Earth system, and we know exactly what it would look like if the Earth is flat, and those measurements always fail.